Okay, good morning, everybody. We're going to practice writing word equations and skeleton equations in this tutorial. So I'm going to start by sharing out my screen just so that you guys can see it. Yep. Oh, wait. Windows. Whiteboard. There we go. Okay. All right, and so what we're going to do now is we're going to look at this word problem and turn it into a word equation, okay? So the big difference between a word problem and a word equation is a word equation uses symbols to represent some of the words. So here we have copper oxide. And sulfuric acid. And it says react to form. This is where you know you need to put in that arrow. And it says copper sulfate. And water. Okay, so this is what's called a word equation. And so our compounds and our elements are represented just by their names, their written out names. Okay, and so I'm going to kind of show you how you can tell where you need to put your arrows. Okay, so I'm looking for my reactants, and it starts off with zinc, so I know that's a reactant. And it says zinc reacts with hydrochloric acid. Okay, so it's reacting with something. That means those are reacting together. So hydrochloric acid is my other reactant. Okay. Then I see the to form. Okay. That's where that arrow is going to go. And sometimes to form will be by itself, or it'll be with a verb like reacts, combines, or react to form. Okay. There are other things that you can look for, things like combusts, replaces. And then I'm going to look for my products. Products are going to be anything on the right-hand side.
Mr. Lash, please come to the office. Mr. Lash, thank you.
Okay. Everything on the right-hand side of that to form. So this the zinc chloride and this hydrogen here. Okay. And then, because I'm writing it out just in word form, I'm going to replace any ands or reacts with, in this case, with a plus sign. So everything on this side added together with an actual symbol. To form is my arrow, and then everything that's in pink will be on the right side. Okay, so we're just writing it out in word form. These are called word equations. Okay. Now there's also this thing called a skeleton equation. And for the most part, when you've seen a chemical equation in your textbook and in practice last quarter, it was a skeleton equation. Skeleton equations use the symbols, but they don't tell you how many of each thing you have. So I'm going to take these first two and I'm going to turn them into skeleton equations as well. So copper oxide, okay, so that's CuO, okay, because you have copper, which is most commonly a 2+ ion, oxygen, which is a 2- ion. They're bonded together. So you'll have your CuO. You crisscross those charges just like we did last time. Down here, there's a 2. Because they're both 2, it becomes Cu1O1, but you don't write ones in when you write a chemical formula, so you just leave it like that. Sulfuric acid, okay, it's okay to look up the chemical formulas if you are not familiar with something like an acid, but sulfuric acid is HSO4. Okay, IC equals ATE. So sulfuric acid is HSO4. Copper sulfate, again, this is an ionic compound, Cu and SO4, 2 plus, 2 minus, CuSO4 is your result. Because these are just going to be 2's down here, and you'll simplify it to 1. So CuSO4, and then water is H2O. You just transfer down your symbols, and you have a skeleton equation. Okay, we're going to do it one more time with the zinc and the hydrochloric acid. Zinc is an element, its symbol is Zn. Hydrochloric acid is HCl. This is a binary acid. Hydro, H, chloric, Cl. Zinc chloride is a compound of zinc and chlorine. So we have Zn and Cl minus. And now I actually don't remember what zinc's most common ion is, so I'm going to check my reference sheet. As soon as I find it, there it is. There we go. Okay. So according to my monatomic metal ion reference, which is right here, you can also find this in the book, zinc only has a 2+ charge. So that's one of the reasons why zinc doesn't have like a Roman numeral. The other reason is these are just randomly generated. So Zn is 2+, chlorine is a 1-. So this is where you guys will actually get to see this crisscross come in handy. So this is a 1-. This will come down here, and it's still going to just be blank. 2 positive is going to come down here and become a 2. So we'll rewrite ZnCl2. This is our compound for zinc chloride. Just like that. And it says plus hydrogen, and hydrogen is always diatomic when it's a gas, so it's H2. So we'll do plus, and there we go. Oh, I forgot the arrow. There. Okay, you've made a skeleton equation. I'm going to just erase my scribbly marks. These are really just like scratch marks for me. All right, there we go. All right, so what I want you to do is with a partner, try the next 2. Magnesium and chlorine to form magnesium chloride. Copper and silver nitrate react to form copper nitrate and silver. Work with your table mate and see if you can complete the next 2.